Hello, Algebra 1. We are working out of section 2.7, solving multi-step equations. These are problems directly from your homework. We're going to start with problem 10, and our instructions are to solve. Identify equations that are identities or that have no solution. So let's look at number 10 first. We have 82b minus 9b plus 7 equals 73b plus 19. There are like terms to combine. So if we look at like terms, that means the constant is a real number. The variable is exactly the same as far as exponents attached, or the number is just a constant. We have a couple of those, so let's look that over. We're going to simplify on the left side of the equation first because we have two like terms, 82b minus 9b. 82b minus 9b is 73b. Everything else transfers down. We rewrite our problem. Now we need to combine like terms but work across the equal sign. So we're going to choose the 73b to get all of the b terms on one side of the equal sign. Subtract 73b from both sides and simplify. Well, 73b minus 73b is 0. We would have 0 plus 7 equals 73b minus 73b is 0, and that leaves 19. Continuing to work, we see that we need to move 7 across the equal sign to combine like terms. Let's do that. It's a positive 7. We're going to subtract 7 from both sides. Whatever operation you do on one side, do on the other to keep equivalency, like we've been talking about. So we simplify again. Plus 7 minus 7 goes away. That leaves 0. Equals 19 minus 7, 12. This is not true, so no solution. Okay, moving on to number 12. We have 7n minus 13 equals 4n minus 9. Again, we're going to look for like terms across the equal sign and combine them. So we'll start with the term that has our variable. We're going to subtract 4n from both sides and simplify. 7n minus 4n is 3n. Everything else from our equation comes down like it was originally written. 4n minus 4n is 0. It goes away. And that leaves a negative 9. We're trying to figure out what n equals. So our next step is to remove the negative 13 from the left side of the equal sign to the right side. It's a negative 13. We're going to add the opposite. To keep equivalency, do the operation on the other side of the equal sign. Simplify. 3n Negative 13 plus 13 goes away, equals negative 9 plus 13. In the margin, that would be like 13 minus 9, and it equals 4. We still can simplify further, so we're going to divide by 3 on both sides. Remember, 3 over 3 equals 1. 1 times n still just equals n in the identity property of multiplication. And that's why we can say we are isolating n by dividing by 3. 3 over 3 is a 1. So 1 times n leaves n. And then we have n equals 4 thirds to solve. All right, let's look at number 16. We have 9a plus 2 minus 6, parenthesis set, a plus 2, end parenthesis set, equals 3a minus 10. Let's simplify everything we can on the left side of the equal sign first. So we're going to start with our gems grouping, which is the negative 6 times a and negative 6 times 2 in the distributive property, because in gems we work with parentheses first. So we'll rewrite everything else up to that point. Negative 6 times a is minus 6a. Negative 6 times 2 is minus 12, equals 3a minus 10. Keep simplifying by combining like terms on the left side. Let's look. We have 9a minus 6a that are like terms. We also have the whole number 2 and negative 12 that are like terms. Let's simplify all of those. 9a minus 6a leaves 3a. Positive 2 minus 12. Let's look in the margin. Positive 2 minus 12 equals. We can also rename this as 2 minus 12, where we do this step, and we say plus a negative 12. Just reminding ourselves, the absolute value of negative 12 is 12. It is the larger absolute value compared to the absolute value of 2 is 2. So the negative sign carries with the number that has the largest absolute value, and that's 12. So we will have more negative in our answer than positive because of our absolute value rule. So 2 plus a negative 12 is a negative 10. So minus 10 equals, carry everything else down from the other side of the equal sign. 3a minus 10. What do you notice about both sides of the equal sign? They're the same. So what this means is that a could equal anything in the set of all real numbers. So we have the identity property here. And we got there by simplifying everything on one side of the equal sign first, and then we noticed the pattern. I hope this helps with your assignment, and look for other videos to be loaded to your playlist for your grade on my YouTube channel, and I'll see you soon.